Hello, calculus type people. Hope you're all having a fantastic day. It's a beautiful day outside. Today we're going to be talking about the integration of e and the natural log. It's going to be an awesome little experience here. If you remember, e is kind of the baby of calculus, right? We all love it, and it's so cute, and we love it because it never changes, right? The derivative of e to the x is e to the x. So the integral is something similar, and we'll get to that here in a second. The natural log of x, a little bit different story, but pretty much along the same lines here. So I want to start off with this. Forget this down here for just a second. Let's just focus on this little paragraph up here, and let's kind of break it apart. It says the antiderivative of 1 over x. Since the derivative of the natural log of x is 1 over x, do it this way. Since the derivative of the natural log is 1 over x, right? 1 over whatever your value is in there for x, then the antiderivative of 1 over x must be the natural log. So if you work backwards, the antiderivative of this gives you the natural log plus c. For everywhere where x is bigger than 0. X has to be bigger than 0. You can't take the natural log of a negative. On the flip side, since the derivative of the natural log minus x is going to be 1 over negative x times negative 1, then that ends up with 1 over x. See what you're doing here? I'm sorry, there should have been a parentheses in here. You're taking out the negative from the x. So you pull out the negative from the x, and then you can just call it the 1 over negative x times negative 1, which again is 1 over x. So we can never end up with a negative result. Then the antiderivative of 1 over x dx is the natural log minus x of negative x plus c. Now, we'll get to what all this means here in this little bubble down here for when x is less than 0. So there is a split between when x is greater than 0 and when x is less than 0. And if you remember, the difference here, plugging in the negative x, has a lot to deal with this absolute value. Since the absolute value of x is x when x is greater than 0, and it's negative x when x is less than 0, right? Then we have the integral of 1 over x dx is the natural log of the absolute value of x plus c. This giant paragraph up here was just to explain that when you take the integral of 1 over x, you get the natural log of x. But this has to be inside of an absolute value because we have to account for the fact that it cannot be negative. Okay? So, long story short, look at the bubble. And then, of course, down here, the more obvious one is their integration, the antiderivative of e to the x dx is e to the x plus c. So the integral of e to the x is e to the x plus c. Now, we're not going to do something so simple as this. We're going to jump straight into our u substitution idea. Number 1, it says the integral of x e to the negative x squared dx. Alright, so a couple of things here. I've got x e to the negative x squared dx. I'm going to have to use u substitution because this is e to the u, isn't it? This is e to the u, so I'm going to go ahead and I'm going to call u negative x squared. See, we've used u before, right? The derivative of e to the u is e to the u du. We've used this stuff before. Now I'm just going to use it for integration. So this should be a little bit of an easier step to make. So u is negative x squared. That means that du is going to be negative 2x dx. And the x I am going to need, I do have an x, so let me go ahead and circle some stuff here. This is going to be my u. But I need to get rid of this negative 2, so this will be times a negative 1/2. X dx is negative 1/2 du. Negative 1/2 du. Okay? So what I end up with is negative 1/2 times the integral of u du. See, I pulled that negative 1/2 out. Oh, wait, I'm sorry, u. Good grief. E to the u. Where's my e? Good night. Okay. So I've got e to the u times negative 1/2 du, and I can go ahead and pull that negative 1/2 out. So that's going to be negative 1/2 times, what's the integral of e to the u? Well, it's e to the u plus c. And then when we distribute our negative 1/2 through, we'll have negative 1/2 e, let's go ahead and plug in u, to the negative x squared plus c. That's all there is to it. Ain't nothing to it but to do it. So again, I changed my exponent to u, came over here and took out the negative 1/2, integrated, I got e to the u plus c. Plug in u, distribute your negative 1/2, and you know that c times negative 1/2 is still just c. Example number 2. Okay, the first thing I would do here, because I've got the natural log squared of z. Hey, that looks weird. I'm going to rewrite this as the natural log of z in parentheses squared over z. And this is dz with respect to z. So the first thing I do is rewrite it, because if you try and do a u substitution straight from here, that's going to look weird. So if you rewrite it with the natural log of z squared, it's pretty easy to see the natural log of z should be your u. So I'm going to call u the natural log of z. I've never been able to write a z properly. So the derivative, du, is going to be 1 over z dz. The derivative of the natural log of z is 1 over z. And you know, you have your dz here, so you multiply it over here. So 1 over z dz. So I've got u, and I've got du. See that 1 over z right here? It's already taken care of. So this is going to be the integral of u squared, don't forget your square, du. That one's easy to do. U to the third over 3 plus c, which is the natural log of z cubed over 3 plus c. It's not too bad, is it? Once you get the idea of u substitution down, it's pretty much just applying it to different situations. That's the practice from that point on. All right? Now, a lot of people would look at number 3 and get intimidated. I look at number 3 and I look for a u. So I've got down on the bottom here, looks like I've got x plus e to the x should be my u because it's inside of the square root here. It'd be the inside of a chain rule. So I'm going to call u x plus e to the x. And let's du it. Derivative of x is 1 plus the derivative of e to the x is e to the x. And dx, yay, look at this. Look at us going. Now, when your d of x was over here, right, and you multiplied it over here, so it's important to remember that it's more like this with parentheses. It's 1 plus e to the x, all of that d to the x, or times dx rather. So let's see what we got. We've got u, 1 plus e to the x dx. We've got du. So this one actually simplifies pretty quickly into the integral of, now this is 1 over the square root of u. So let's call it u to the negative 1/2 du. Right? Integrate that. We'll have u to the 1/2 over 1/2, which we will simplify here in just a moment, plus c, which is going to be 2u to the 1/2 plus c, which is going to be 2 times the square root of x plus e to the x plus c. See, it's not too bad. It is not too shabby. One last one here. Number 4. Oops, I just realized it's kind of dark. I should have brightened this up. Give me brightness. Little better. Okay. The integral of t over 1 plus 3t squared dt. Okay, now on this one, this is one of those ones, do you have to do this one as a chain rule? That's what I would look at. And in this case, absolutely you have to do this one as a chain rule. You've got a complex denominator here. So I've got to call this whole thing, for u, I've got to call it 1 plus 3t squared. The first thing I looked at, is there any way I can split this denominator? And no, it doesn't work. So I've got u is 1 plus 3t squared, so du, the derivative of 1 is 0, so this will be 6t dt. Alright, and I've got a t dt, but I don't have a 6, so I'm going to get rid of that 6 there, or multiply by 1 over 6 instead of dividing. It makes it a little bit easier to see. So I've got u is all this. I've got 1 over 6 du is this. So let's write down what we've got here, just to kind of clear the setup for a second. I've got my 1/6, ding, and I've got 1 over u and du. Now, I know what you would want to do here, because it's the same thing when I first learned this, it's the same thing I always wanted to do. Well, why not just make this, and I'm going to do it over here so you can kind of see what's going to happen. Why not just make this 1/6 the integral of u to the negative 1 du? Well, that's all fine and dandy until you go to add 1 to your exponent here, and you end up getting u to the 0 over 0. See, that's why this rule came about, because we got to this point and we're like, what? So we figured out we can't do that. If we have a solid negative 1 right there, we can't do that. So I'm going to get that out of here. Get rid of that. Get out of here. Alright, so I've got 1 over 6, the integral of 1 over u du. Okay, so I'm going to go back to here. It's a little bit newer, so I haven't seen this. 1 over u du, 1 over x dx. Shouldn't that be the natural log of u plus c? So this is what this is going to leave me with then is 1/6 times the natural log of u plus c. Alright, now back here, this should be the absolute value, right? Don't forget that absolute value. So I'm going to go ahead and drop those in here now so that I don't forget them later. So when you integrate the natural log, got to be the absolute value. You can't take a natural log of a negative number. This is 1 over 6, natural log. Go ahead and plug in u again. 1 plus 3t squared plus c. Now, just as a side note, I do want to write this down. This is the answer and it is correct, but I do want to write this down. You could see this question on the multiple choice section answered like this: 1 plus 3t squared plus c, without the absolute values. Now, this could be on the multiple choice test, so I want you to write this down here, and I'll explain why in a second. This could be on the multiple choice test as the answer. Now think about why that is. Why would they be able to drop the absolute values off of that? They won't do it by mistake. They won't do it unless they can. The reason they can drop the absolute values on that is because 1 plus 3t squared will never be negative. Plug in anything you want into t. A negative number squared is positive, a positive number squared is positive. This will always be positive. And you're adding 1 to it. So, the reason for this is since 1 plus 3t squared can never be negative. So because it can never be negative, they can kind of disregard the absolute values. And they will do it because they're trying to see if you would catch up to it. Okay. Now, they wouldn't have both of these because they're both correct. They would not have both of these. They would just have one of them on the multiple choice test. But I just wanted to kind of give you a glimpse into that because you need to know. You need to know that if they can simplify it down to a shorter portion or to a shorter equation, that they're going to do everything in their power that they can to do that. So just kind of be aware of that, and we'll have a fantastic time.